In this video, we examine the role that buoyancy plays in thunderstorm forecasting. Thunderstorm requires three ingredients to come together. The first is moisture to form the cloud. The second is instability, because we're looking at forming convective cloud. And the third is a lifting mechanism to enable parcels to reach their level of free convection. And wind shear is also important, but we'll develop that in another context. So here we have two traces, and we're looking at the potential for surface-based convective cloud. On the left, we have instability, but we also can see that the values of dew point are very, very low, so we don't have sufficient moisture to produce cloud. On the right-hand side, you can see we have sufficient moisture with very high dew points, but the environment looks quite stable. And so the sample cloud saturated adiabat, indicated in grey, is to the left of the temperature trace, and so clearly this is not a convective cloud situation at all. So we need both moisture and instability. If the parcel is unsaturated, it will follow the dry adiabat. Conversely, the dew point will follow a constant mixing ratio line. Shown in this figure here is a temperature profile and the mean mixing ratio for the lowest 50 hectopascals. And this is the value that will be used in convective calculations. So we lift the parcel along a dry adiabat and along the line of constant mixing ratio, and we arrive at a condensation level. When the dry adiabat crosses the constant mixing ratio, the air becomes saturated and convection commences. This is the level of free convection. And if the parcel remains buoyant, a cumulus, towering cumulus, or cumulonimbus cloud forms, because the parcel is now going to proceed along a saturated adiabat. So as long as the environment traces on the cooler side of the lifted parcel, that is, the parcel is warmer than its environment, then we have sufficient instability for convection. And convection is simply defined as parcel ascent where no forced lifting is required. And so you can see as the parcel rises along the saturated adiabat, cloud of the convective variety can form.